Let's continue in this video with our problem of the stroke reaction. Compute an estimate of sigma, the standard deviation of my model, and give a practical interpretation of this estimate. Remember, our model was this line. That is our mathematical model. We want to obtain the standard deviation of my model. This means we need to obtain this formula first, the estimate when given any value, we want to estimate the value of y using this mathematical model. We can obtain the deviation respect to my expectation because this is the expected value. This is the expected value according to my model. But the true value, that the value in my sample could be this one for x. Then this distance is the error in my estimation. That is the error in my model. And we can sum all of this error and we can obtain the average of all of this deviation. But first we need to square, as we did it when we obtained the standard deviation for x, we obtain the deviation of each value respect to the mean and square all of this deviation, sum all of the deviation and divide it by n. When it's a sample, we need to divide by the degree of freedom, which is n minus 1, and take the square root of this quantity. We are going to do the same. We are going to obtain the deviation respect to my model. My model will be here, will be given by y bar, my expected value of y. Then the deviation should be obtained like y, the actual value, minus my expectation. We square all of this quantity and we sum all of the deviation squared. That will be my sum of all square deviation respect to my model. And the standard deviation should be the sum of a square error divided by, in this case, the degree of freedom will be n minus 2, because here we use only one means to obtain this standard deviation respect to this mean. But in this case, because we have two variables, we obtain the deviation respect to two means, y bar and x bar. For that reason, we need to subtract 2 degrees of freedom, okay? And the formula is given by the square root of this quantity, okay? That is the objective in this problem. First of all, this is the formula for the variance. The variance is without the square root, but we need to find the sum of all square divided by n minus 2. Remember, the formula for the sum of a square error is this, but there is a shortcut formula for that. The shortcut formula is given by the sum of all y, sum of square of all y, minus b sub 1 estimated times the sum of all square of all xy. That is the shortcut formula instead this one that is more complicated. Then for that reason we need this formula, and we can compute this formula using the result that we obtain in Excel. If we go to Excel, then the sum of square error will be equal the sum of square of all y, that is the deviation of all of this value respect to the mean, minus b sub 1 that we obtained in the previous exercise, times the sum of the square of all xy, this quantity. That is the sum of the square error. The variance is this sum of a square divided by the degree of freedom. The degree of freedom, because we have 5 pair of value minus 2, then is equal this value divided by 5 minus 2 degrees of 2 is equal 3, is the degree of freedom. That is the variance of my model. The standard deviation of my model will be the square root of this quantity. We can obtain the standard deviation using the original formula for the standard deviation for the sum of a square error. Actually, that is the variance. We can obtain this doing this, obtaining the deviation of each value respect to the model. Square all of this deviation and divide it by n minus 2. But the shortcut formula is better. The shortcut for this formula will be the sum of a square of all y minus b1, the sum of a square of all xy divided by n minus 2. In this case, this value was this sum of square, this quantity equal 1.1 using this shortcut formula. We can obtain the same value using the original formula. How can we do that? Let's name this column model. The model predicts the value of y given x. This value is equal b sub 0 plus b sub 1 times x. If we want to copy this formula in all of these cells, we need to fix in this formula my constant. Then let's use dollar symbol. Let's use dollar symbol in all these cases. Dollar symbol to fix these values in my formula, because I will copy all of this formula in all of these cells. Okay, that is the formula. Then let's copy this formula in all of these cells. That is my model. That is my expectation. That could be interpreted as the mean for all values when we have this cloud of points, when we have the entire population. Then given one value, for example, given 1, if we measure in the population all people that receive 1% of this drug, we can measure all of this value in the population and we can obtain all of these points. Then the mean of all of these points should be on this line. That is my y expectation for all of these values. If we obtain y minus y hat, then we have to be y minus the expected value for y when x is equal 1, and we can copy this formula here. Also, we can obtain y minus y hat squared raised to the second power. Then that is equal this value raised to the second power. Then when we copy this formula for all values and we sum all of these squares deviation, we obtain exactly the same value that we obtain using this shortcut formula. Okay, but I recommend to use this shortcut formula instead this one. We have all of this value obtained in Excel. Then we need to substitute all of this value here. That's it. Then the sum of all y is 6 minus b sub 1, which is 0.7, minus the sum of all xy that is given by here is 0.7. 0.7 times 7. Then the product of all of these, you can verify, must be equal 1.1. Okay, you don't have to do the operation manually, but you have to do it in Excel. And when we substitute the sum of all square error here in this formula for the standard deviation of my model, the variance of my model, then we need to divide the sum of all square deviation by the degree of freedom. And this result is given here. You can find this result in the printout. And the standard deviation is the square root of the variance. And the square root of the variance is 0.60. That is the interpretation. This is the result. The interpretation is the standard deviation of my model is a measure of all deviation of the value respect to my model. It's a measure of the deviation. Here we can obtain in StatCrunch 1.1 is the sum of square error, and the variance is this value 0.0. When we divide the sum of square by the degree of freedom, we obtain the variance. The standard deviation is the square root of the variance, is 0.6 and is given here. And this is a printout of another software, SAS. We can interpret the standard deviation of my model as the standard deviation of the error of my model. Remember, my model predicts the value of y given x. If we plot the entire population in this graph, we are going to observe a cloud of points around my mathematical model. Remember, the standard deviation could be approached by the standard deviation in my model for this one. But if you plot in this graph all value of y and x for all pairs in the population, all pairs in this graph, 95% of all points will be inside 2 standard deviation.